Welcome back. In the last video, we created a list of examples that we can pass to our Gradio interface demo. And I left you off with a pretty big challenge of creating a Gradio interface to go from input, map it to a function, in other words, our predict function up here, and then creating some kind of output. Now, that's a fairly big challenge because we've never used Gradio before, but it's nothing I don't think you can handle. So I trust you gave it a shot, but let's now do it together. So I'm going to import Gradio as GR. We don't have to anymore, but I'm going to do it anyway. And I'm going to create some niceness around our demo. So a title, description, and article. So if we come into the Gradio documentation, you can see title. Title is a title for the interface if provided, appears above the input. A description tells people what's going on, and you can put in Markdown and HTML here. And then the article is an expanded article explaining the interface. So it's all about communication here, right? Like this is the title, this is the description, and this is the article, just so people know what's going on. This is, hey, this is Food Vision Mini, here's what it does, and here's where we created it. So let's create some info. Title equals Food Vision Mini, and of course, you can customize it for your own source. So I just pressed on my keyboard, I'm working on Mac, is Command Space and Control to get the emojis, Command Space and Control. I know it might be a little different depending on the machine you're working on, but this is pizza, steak, and sushi. But of course, you could always just come into here and copy that, or come into here and copy this. I'm giving away some spoilers here, you know. There we go. So let's go create a description. So what's our description going to be? Well, let's keep it simple. An efficient net B2 feature extractor, computer vision model to classify images as pizza, steak, or sushi. Nice and simple. And then if you wanted to, you could link in here. So Torch Vision FNet B2, is that going to show up? No, it doesn't, because that's our Torch Vision models. That's our little acronym for Efficient Net B2. I'll just show you a cool thing, is if we go down, is Efficient Net here? Efficient Net B2. There we go. If you wanted to link this, it supports Markdown. So we could link that in there. Wonderful. We'll see if that works in a second. The article, what's this going to be? Created at, this is just saying where the model was created at. That way people, if they want to see the code, can go and find it. PyTorch model deployment. And then we can, of course, link this in there. Using Markdown style, put it in there. Wonderful. So we've got the title, description, and article. Now let's create the Gradio demo. You might have already done this. And if you have, well, I hope it looks cool. We're going to see it together in a second. So gr.interface. So this is the main class in Gradio, an interface. And here's where we need to define our function, which is what's going to map our maps inputs to outputs, and we just pass it in like that. So that's our predict function that we created up here. Of course, depending on what your inputs and outputs will be, will define what goes into your predict function or your mapping function. This could be almost anything. And depending on what your inputs, such as numbers, you might want to map numbers to some kind of graph. So you could probably do that with Gradio. Or you might want to map some kind of text file to an image, which is what Stable Diffusion does. Oh, spoiler, steak dinner, this is what it generated. That looks pretty good. We're going to try one of these with our Gradio demo in a second. And let's now map our inputs, or set up our inputs. We can do this by going image. That's like in the Gradio demo here. It could be just a string. So inputs is a string. Or a component. I like to do it as a component. gr.image, and the type of image we want is pill, for Python image library. And then outputs, this one's a little bit tricky, but nothing we can't handle. Our output is going to be a gr.label, and I'm passing in a list because I want multiple outputs. This is one output here, this, how could you say, module, and this is another output. So we have two outputs there. So that's why I'm passing in a list. There we go, one output, another output. So let's do this, gr label and num top classes equals 3. This is why we output in a prediction dictionary here. Because we have 3 classes, if you had 1,000 classes, you could still put number of top classes equals 3. It will only show you the top 3 classes. So this is just for aesthetic purposes. We only have 3 classes, so we only have to map to 3. But if there was 10 or 50, you could still map the top 5, you could map the top 10, you could map the top 1. But let's keep going. And then we're going to put here the label equals predictions. And this is just for, so that we label this as predictions and this is prediction time. That's our labels. Wonderful. Now let's keep going. The next one we want is a gr number. This is going to be the prediction time. So all we have to do is pass in here prediction time and then seconds. Wonderful. So what's next? Well, let's pass in our examples, which is of course going to be our example list that we created in the last video. So this is examples here. And then what else do we want? We want to pass in our title, which is the title string that we have above. Then the description, which is going to be the description string above as well. And then finally the article, which is going to be the article string. And then we are on the way to launching the demo. Let's do this. Demo.launch. This is going to take off. So this is a launch. The launch method is associated with the interface class. So if we have launch, there we go, gradio.interface.launch. Launch is a simple web server that serves the demo. That's exactly what we want. Can also be used to create a public link. Oh my goodness. Let's not let any spoilers get in the way here. I'm going to set debug equal to false. So if you want to print errors locally in Google Colab, you can do that with debug. But if we want to share it, we'll set share equals true. And so let's go generate a publicly shareable URL. So you ready? We're going to bring Food Vision Mini to life in a Gradio demo. In 3, 2, 1, no errors. If in doubt, run the code. Here we go. Colab notebook detected to show errors in Google Colab. Debug equals true. There we go. Running on public URL. Some numbers here, .gradio.app. Now this share link expires in 72 hours. So by the time you read this, it'll probably be expired. But for permanent hosting, you can check out huggingface.co/spaces. We're going to look at that later. Here we go. Look at Food Vision Mini. There's our efficient NP2 feature extractor link. And here's our created at 09 PyTorch model deployment. Wonderful, wonderful. The links work. But now we've got our examples. We can upload them, submit, and let's see what happens. Sushi, beautiful. Let's submit this one. What do we get? Pizza. And then finally, pizza. Oh, look at that. That is so beautiful. So if we go up here, these are from our examples dictionary or our examples list. So we've got 1 image of sushi and 2 of pizza because of course they're selected as random. And then if we wanted to try it on our own image, what could we do? I could upload this image. It's got a steak in it. So what do we get? Steak. Beautiful. And then of course, the flag button here is if we flag it, this is helpful for figuring out where your model goes wrong. So this is going to generate a directory with images in here that have been marked as wrong. But I'll leave that as an extension for you to look into of how you can use the flag button here. For now, let's look at our app running on the internet. So if you were to access this within 72 hours of me launching this here, you would get this say, oh, there's our Food Vision Mini running on the internet. Yes! So of course, as I said, this will only last for 72 hours, so it probably won't work by the time you see it, but this is the same app running as here. We've just hosted it permanently on Hugging Face Spaces. So how about we try out our Food Vision Mini demo with, this is the spoiler from before, a steak dinner generated by Stable Diffusion Demo. This is like meta machine learning. We've generated an image using machine learning, and then we're going to classify it using machine learning. So I'm going to download this image, or maybe I can just drag and drop it, hey? Can I go into this tab? Maybe that didn't work. I want to go there, and then this one, I'll go there. Split it up. Let's try this. Oh, not working. I'm going to save this as steak. There we go. How's it going to go? Steak. Oh my gosh, how cool is that? So we generated an image using a machine learning Gradio demo, and then we classified that image using a machine learning Gradio demo. So congratulations, you've just brought, or we've just brought, Food Vision Mini to life through the power of a Gradio demo. So that's how powerful Gradio is. Within a few videos, we've gone from not knowing anything about it, installing it, to deploying our machine learning model as a demo that we could share with anyone. Now, this link is of course going to expire in 72 hours, so we couldn't share it after that. Now let's work towards hosting it permanently on Hugging Face Spaces. And in fact, you might want to jump ahead and see how you can do this. To do so, we're going to need a Hugging Face account. So I've signed up for a free one here. This is my profile, Mr. D. Burke. You can get a spoiler of what it's going to look like, of course, at this link here. So jump into the documentation there for Hugging Face Spaces. So you can search this as going Hugging Face Spaces docs and have a little bit of a read, have a play around and see how we can, yeah, there we go. Hugging Face Spaces offer a simple way to host ML demo apps. See how we might be able to host our Gradio app. But we're going to explore this together over the next few videos. So I'll see you there.